This is the Introduction to Data Science, Assignment 1. Understanding business problems from a data science perspective. Section 1. Framing business problems as analytics problems. Question 1. We must discuss how we can objectively measure Bono's performance. We came up with 4 objective measurement indexes. The first is BMI and BMR. BMI is body mass index, and BMR is basal metabolic rate. This is an effective method for setting a starting point as well as planning performance and measurement tasks. BMI is a common measurement. It allows us to set a good baseline and allows us to measure overall progress and can be measured weekly. Our basal metabolic rate, or BMR, is the number of calories required for the body to function at rest. Knowing the BMR ensures that we can design tasks that will efficiently counter calorie intake. Knowing calorie intake and the BMR allows us to calculate the total daily energy expenditure, the TDEE. Once we have figured out the TDEE, we can determine if the calorie intake is greater than the TDEE, this will result in weight gain, and if the calorie intake is less than the TDEE, it will result in weight loss. Since Bono is overweight, we will ensure that his calorie intake is less than his TDEE to ensure weight loss. The second index is body measurements. We measure the neck, chest, arms, waist, hips, and thighs. These are all trackable for performance and progress. We're able to set a baseline which is determined by his height, his weight, and his body type. It is a very simple, continual progress measurement that can be done weekly. Third is calorie intake. The calorie intake measurements will occur via a regimented diet. It will act as a control for our performance tracking. The regimented diet will include 20 choice of meals that are predetermined by the fitness trainer, and Bono will be limited to 3 meals per day only. For example, Bono might have cereal or muesli for breakfast, a simple meat, simple vegetable, and some small carbohydrates for lunch, fruits and small carbs for dinner. Meals will occur at relatively the same time each day. The consistency of the workouts and the meals will allow us to ensure the overall increased effectiveness of the workout and the program. Calorie and nutritional intake will be measured daily. Finally, the last index are the duration and type of workouts. We will design performance tasks for which measurements can be made. This is required to ensure that all calorie intake is regulated and accounted for. There are 5 categories of activity. First is sedentary, with little to no activities per week. Next is slightly active, with 1 to 3 days activities per week. Then moderately active, with 3 to 5 days per week. Very active, with 6 or 7 days per week. And then extra active, with activities being done once or twice per day, or being very active with the inclusion of a very physical and difficult job, such as doing hard labor. Given Bono's current condition, he will start off at the sedentary category. The duration and type of workout are sure to change over time. However, we will start with a focus on weight loss through cardio. We will target a minimum of 200 calories burned per session, with the option for Bono to do extra according to his capabilities.
Now, question 2 asks us to explain the kinds of data that need to be collected to allow us to measure Bono's performance. Now, we have 2 kinds of data, static data and dynamic data, with static data being defined as data that does not change after being recorded. It's a fixed data set. And dynamic data being data that may change after it's been recorded and has to be continually updated. Now, as you can see from the list, static data, what we'll be looking at would be name, height, sex, birthday, blood group, body type, and allergies. Whilst under dynamic data, we have weight, kinds of workouts you'll be taking, there's nutritional intake, and body measurements. We cannot ignore categorical and numerical data as well. That is also important here. And name, sex, blood group, body type, and allergies would fall And his workouts would fall under categorical, whilst numerical data would include his height, age, his weight, the nutritional intake, and his body measurements.
Question 3. As we train Bono, we notice an opportunity to help many others like Bono that share the same problem. Through a mobile app, our fitness training model could be scaled to easily to accommodate hundreds or maybe even thousands of other people from different social demographic profiles. We must first discuss if the initial objective measurement indexes designed for Bono will still hold true in this situation, and if not, what additional type of data need to be collected. The initial objective measurement indexes designed for Bono will still hold true in this situation because our model is designed to accommodate a very general fitness regimen and measurement style. It uses standardized methods of measurement that can be applied to all the potential different social demographics. However, there are numerous new considerations that we must take into account since the desired approach is a mobile app. The mobile app is able to reach many new environments and many new demographics. This means that extra measurement need to be taken to help account for potential variants introduced by these factors. The additional data that needs to be collected are water consumption, the daily consumption of the subject, average consumption per day compared to the minimum required consumption and the ideal consumption amount. Second, nutrient and supplement tracking. An extension of calorie tracking, we track and ensure that all necessary nutrients and vitamins are acquired in appropriate amounts. We also take note of any nutritional supplement taken by the subjects as they will affect progression rates and measurement predictions. Third, region and environment tracking. This affects the availability of dietary items, and certain dietary items may need to be changed, removed, or introduced to accommodate for these variances. Cultural and local eating habits also may play a role in the causing health issues such as Asian foods being high in carbohydrates and therefore having a higher likelihood of causing lethargy.
In question 4, I will discuss how one could handle missing data and point out three different techniques of how missing data can be handled. First, to handling missing data, we need to understand how the missing data will be managed in the analysis to help us determine how much info to be gathered about the missing data. Why should we handle missing data? Handling missing data is an important part of the data matching process that is integral to all data science projects. Missing data can have a significance on the conclusion that can be drawn from data. For example, let's take for a bank, we have data, we want to analyze the data of a customer to see if they are going to pay their loan or not. So if you don't manage or handle the data accurately, the result might be completely wrong, which is not good for the company. So to deal with missing data, we need to first know what type of missingness is the data. There's three type of missingness that I would like to point out here. The first one being missing at random. Missing at random happen when the probability that the responses are missing depends on the set of observed responses but is not related to the specific missing values which are expected to be obtained. The second one is missing completely at random, which means that the probability of missing data variable, let's say y, is unrelated to the true value of y or over observed variables. The third type of missingness is not missing at random. Not missing at random is when the probability of a missing data, let's say y, depends on the variable y itself. So now that I have pointed out the type of missingness, I would move forward to the three type of method techniques that we can be used to handle with missing data. First one being leadwise deletion. Leadwise deletion is one of the simplest method for dealing with handle data, is where you omit the missing data completely. So in the case that in case has missing data for any of the variables, we simply exclude that case from the analysis. It is usually the default in statistical package. One advantage of leadwise deletion is it can be used with any kind of statistical analysis and no special computational method required. Limitation: it can exclude a large fraction of original sample. Let's say half of a data are missing. So you cannot omit all half of the data, because omitting half of the data will probably affect the conclusion that can be drawn from that set of data. And the type of data that it missingness that works well with literal division are when data are missing completely at random, which happens really in reality. The second method that I will point out here is amputation. Amputation methods is one of the best methods to handle missing data. What is amputations? First, let's say that there is two types of amputation. There is single amputation and there is multiple amputation. But here I will just talk about the advantage and disadvantage of general amputation in general. So amputation is when you substitute each missing value for a reasonable guess and then carry out the analysis as if there were no missing values. Which it's important to point out that amputation is an easy way to handle missing data when there is just a few cases are missing, that means less than 5%, let's say. And the type of missingness that work well with amputation are missing completely at random or missing at random. Also, when missing not at random, it can be used, but mostly this one you use a multiple amputation, which is more complex and can deal with missing at random or not missing at random. Um, Limitation of amplitude technique in general will lead to underestimation of standard errors and thus overestimation of test statistic. The main reason is that the imputed values are completely determined by a model applied to the observed data. In other words, they contain no error. And the third technique that I would like to point out is maximum likelihood. Maximum likelihood is a method of estimating the parameters of a statistical model given observations by finding the parameter which the by, by finding the parameter values that maximizes the likelihood of having the observation of making the observation given the parameters. Advantage of maximum likelihood is it gives efficient estimate with correct standard errors. That's amazing. When you use it, it gives quite good results. Maximum likelihood works well with when missing data is missing completely at random or missing at random. And one limitations of maximum likelihood is what it doesn't work for linear models. So if you want to use maximum likelihood, the model has to be linear. With non-linear, you have to use either amputation, which is mostly recommended in most cases. And also with maximum likelihood, you need specialized software that will do and the covariance matrix for the variable and model when thereby giving the results.
Section 2. We must recommend the appropriate analytic technique to answer a specific business question. Question 5. We must contrast 6 different types of analytic techniques or technologies, namely statistics, database querying, data warehousing, regression analysis, machine learning, and data mining. We must compare them in terms of their typical utilization, their strengths, and their weaknesses. First, statistics. It is typically used for the collection and interpretation of strictly numerical data. Its strengths are that once obtained, its values are absolute. Analysis on statistical data can be done quickly because they are purely numerical. It is a standardized method of collection that is widely known and familiar to many professions. However, its weaknesses are the inability to give feedback or opinions since the data is absolute. It is difficult to use for decision making as well since the data is immutable. It requires a verified data source in order for accurate analysis to be done, and it's bad for problem solving and analyzing depth when required. Second, regression analysis. Its typical utilization is it supplements statistics by allowing forecasting to be done specifically through visual representation of datasets. Its strengths are it has a high error and inconsistency detection rate. It is very sensitive to outliers. Its ability to supplement statistics and allow forecasting allows us to support decision making of businesses. New insights can be obtained from the visual representation of data sets as it is easier to uncover previously unseen patterns in statistical data. However, its weaknesses are it requires a specific target variable or subsets in order for regression analysis to be done. It requires also personnel with a specific mindset and skill set in order for the regression analysis to be effective. The data acquired must be independent to ensure variable consistency.
Third is database querying. Typical utilization for this technique is that it retrieves and extracts of pre-existing data that uses SQL to format into tables and tuples for readability. The strength of using this technique is that it has a complex interaction available through a relationship between tables, and it also there's filters available by required or desired category. Other than that, it is used to perpetuate calculation, and there are no coding required where there is a software as it will generate the database table. Down part of using database querying as part of analytic technique is that you need SQL knowledge and know-how is essential, and database is need to be normalized in order to have a proper database. Other than that, database must have redundancy to be removed, and there is ineffective unstructured data. Fourth is data warehousing. Typical utilization for this analytic technique is that there's a collection of data unstructured from diverse sources, and initial data transformation will take place. Strength of this technique is that it supports decision making as data comes from a variety of sources. Multiple warehouses are a possibility for backups and scalable reporting processes. And lastly, inconsistency can be identified quickly and it can be removed. Disadvantage of using data warehousing as part of analytic technique is that the data is not synchronized from source to source, as some department or sources may need to wait on other prior to sending their own data. Other than that, the data that is collected has lack of structure, and to maintain this data warehousing is not cheap, can be costly, and lastly, data collected is relevant now, but it will become less relevant and useful over time.
Number five, machine learning. Now, machine learning is a field of computer science that gives computers the ability to learn without being explicitly programmed. The typical utilization of machine learning works as an AI that uncovers varied patterns in large volumes of data autonomously. Machine learning tasks are typically classified into three broad categories depending on the nature of the learning signal or the feedback available to the learning system. These three categories are supervised learning, unsupervised learning, and reinforcement learning. Now, supervised learning is where computers presented with example inputs and their desired outputs given by a teacher, and the goal is to learn a general rule that maps inputs to outputs. In unsupervised learning, no labels are given to learning the algorithm, leaving the computer on its own to find structure in the inputs. And in reinforcement learning, a computer program interacts with a dynamic environment in which it must perform a certain goal, for example, driving a vehicle or playing a game against an opponent. The program's provided feedback in terms of rewards and punishments as it navigates its problem space. Now, to focus on the strengths and weaknesses of machine learning. The strengths of machine learning would be the ability to process large volumes of data, as computers are faster than human brains in logical and numerical computing. They're self-scalable, meaning that a learning algorithm can deal with any amount of data without consuming an ever-growing amount of resources like memory. This is possible with SGD algorithms, SGD standing for stochastic gradient descent algorithms, and they're also human error free. Now, the weaknesses of machine learning would be depending on which action needs to be taken and when various machine learning techniques need to be tried. Acquisition of relevant data is usually a challenge. A lack of human context sensitivity is also an issue with machine learning, where if a bias exists in the data, the algorithm will perpetuate that bias. and the limited scope of machine learning. For example, when we're trying to distinguish cats from dogs, but machine learning can't distinguish or identify different breeds of cats. It works in a limited scope of variables, and the minute a single variable is changed, it will fail to execute perfectly. For example, dressing up a cat as a dog would probably be an issue if the program is asked to identify the variable as a cat or a dog.
Number 5, data mining. Data mining is an important part of knowledge discovery process that can analyze an enormous set of data and get hidden and useful knowledge. Typical utilization of data mining. Sorting. Data mining can sort through large datasets to identify patterns and establish relationships to solve problems through data analysis. Some of the strengths, it can predict future, fraud detection, speed up research, and aid in decision making. It can also help in government. For example, in government, data mining helps the government agency by digging and analyzing records of financial transactions and to build patterns that can detect laundering, money laundering, and criminal activities. Also in marketing, data mining helps to build model based on historical data to predict how a customer will respond to a new marketing campaign. Some weaknesses of data mining, privacy of user at risk, because as you know, since the internet is booming on social network, privacy has been an issue, and security risk because is a big issue because business owns information about employees and customers, for example, the social security, the birth date, and payroll. So this data has to be handled properly so that it remains confidential. And also, data mining involves an overwhelming amount of data, and there is possible of misuse or misappropriation of the data.
Question 6. We must determine and argue the most appropriate analytics technique for answering the following business questions. Question A. Who are the most profitable customers? The technique we agreed on using is linear regression. We choose to use linear regression because there is a need to visualize data. The most profitable customers are also outliers. In this way, linear regression is appropriate for identifying it. We must identify the most profitable customers by uncovering the patterns and characteristics that differentiate profitable customers from non-profitable and average customers. They will display certain behaviors that will be observable through linear regression.
Question 6, part B. Is there really a difference between the profitable customer and the average customer? So the technique we decided to use for this particular question is statistics. Why statistics? Because to see the difference between profitable customers and average customers, we need to see numbers. For example, if take for example we want to see the difference between profitable customers and average customers at McDonald's, we need to see how much we buy and how many we buy. So for this particular purpose, we believe that statistics is the proper technique. So argument is like I said before, we observed and analyzed collected statistics for customer. Analysis of the data can be done quickly because we need to know the difference quickly, and also with key differences in spending amounts, immediate discernible from collected values. What do you mean by that? When once we collect the data, the numbers, we can analyze it, process it, do some mathematics with it, so that at the end of the day, when we have the end values, we can look and compare those values, which will determine whether the customer is a profitable customer or an average customer.
Number 6. C. Which characteristics really differentiate profitable customers from the unprofitable ones? Now, the techniques we considered prior were machine learning and statistics, but eventually we came to the conclusion that data mining would be the best technique for determining the profitable customers from the unprofitable ones. And our argument being, we need to track all customer patterns from all possible sources, resulting in an extremely large set of data that would require data mining. This large and comprehensive dataset allows us to assess the differences between typically profitable customers and unprofitable customers.
Question D. Will some particular new customers be eventually profitable? Our team decided that The most appropriate analytic technique for for the business question is machine learning. Why? Because we argue that we utilize machine learning processes on the customer data once an algorithm for identifying profitable customer is crafted, at which point machine learning will be able to identify subtle patterns and behavioral tendencies that indicate a customer will become profitable in the future. That is the end of our presentation. Thank you, and we're group 15.